Excellent. Good morning, everybody. We're just going to wait a couple more minutes until we have a few more attendees in, and then we'll get started. So, a couple of minutes, and we'll get cracking with the webinar. Okay, a few more coming in. All right. I think we may just push on. So, again, welcome, and welcome to the webinar for AirMet Scientific. Today, we're talking about real-time dust monitoring solutions for today and tomorrow. So it's a subject that Shane and I are very passionate about, and also very passionate about bringing innovative solutions to our customers for field use in the protection of people and environment. So I'm Andrew Marom. I'm the National Sales Manager for AirMet Scientific, and we'll be talking to you today about the real-time dust monitoring, our solutions that we have currently in the range, and also asking of you your input onto what we can do to pioneer and innovate the solutions for real-time dust monitoring in the future. So a little bit of housekeeping. We'll go through what we're talking about today in our webinar. So we're going to cover the current personal dust monitoring techniques. So that's instruments like gravimetric sampling via SKC pumps. We're then going to be talking about real-time dust monitors and the potential that real-time dust monitors can unlock, and also addressing technical limitations that real-time dust monitoring can pose, and also envisaging a future state. So we'll then move into our static monitoring techniques, the opportunities and solutions for fixed and static monitors. And as discussed with the questions there, we're going to get an interactive discussion. So you get to have your say about shaping the future of personal dust monitoring and platform-based solutions, utilizing the domains of personal, static, and platform systems to get the best outputs for workers and for safety professionals as well, applying those in practice. And then we close out with our Q&A session. All right, on with the show. So current state of personal monitoring, we have techniques such as the gravimetric filter method. So we're using sampling pumps such as the SKC range of pumps there, shown in the touch. We have an IOM and also another filter cassette there that we're using, Cyclone. And those are the gold standard of monitoring instrumentation. So that's where you're setting up in the worker in the breathing zone, using a sample media and a sample cassette or accessory determined for your contaminant of concern. And then you're taking those results over, say, the workday or a period of monitoring, and having them analyzed at the lab. So what you get with gravimetric monitoring is that it's a compliance grade sample that you're taking. It is the gold standard. We have it sent to the lab for analysis. So you can look at things like your respirable dust levels, and also concentration of things, contaminants of concerns like RCS or diesel particulate matter. So again, tried and tested, long-standing range of instrumentation there. Pump is providing a flow rate very accurately over your filter sampling train, and you're able to determine what that worker has been exposed to, or if you're getting migration of the boundary, also what, say, fibers are migrating from the boundary of your site. We then move into personal real-time dust monitors, such as we're visualizing with the DustCanary. That's a new product for us in the AirMet range, which has been actually brought in-house as an AirMet brand. That is a simple, easy-to-use, respirable personal dust monitor, providing real-time results for field use. You wear it in the breathing zone on the worker, and it allows you to deploy multiple real-time monitors without much impact to the worker who's wearing that device. So very discrete sampler. It's utilizing a little bit of gas detection pedigree in that it can give you alarms using things like an audible and a visual indicator. Clips onto your breathing zone, and a very, very simple and easy to use tool in the safety professionals toolkit. So it gives you a high level of detail on what's happening on your sites, and able to be deployed in multiple people. So we can actually see at one time a lot of data and collect mass data in practice. So a very, very nice inclusion to the range with the DustCanary. We then move on to devices such as the Nanozen dust count. So that is another personal real-time dust monitor. Difference being, on a Nanozen, you have a 25mm filter collection ability on the Nanozen. which is one of the key differences between that and the DustCanary. You're able to use a size selective impactor on that device. So fantastic that you can get a mass concentration, say on a PM10, PM4, or PM2.5, but you can also look at the spectrum particles below that impactor size selection. So from an investigative standpoint, the Nanozin dust count is an excellent tool for anybody who's looking to find out if their dust collectors are working, if the local exhaust ventilation systems are operating at full optimization. And they've certainly been used to great effect in the field, in mining applications, process plant and refineries. So a really, really excellent tool when you're digging into more detailed data and finding out about how you're actually going to treat that dust risk that you have on your site. So if I can see that the makeup of particles is made up of nanoparticles, because my device is telling me that 70% of that is nanoparticles on my Nanozin, then I can actually treat that risk with a finer mist or a extraction tool. So I'm able to actually understand how my controls are operating and if they're effective. So a fantastic tool from that perspective. Onto the potential of real-time dust monitoring. You're going to have a greater understanding of where your exceedances occur. So one of the limitations of your gravimetric sample collection method at the moment is that you take the sample, you're going to have that packaged up and sent to the lab. Lab will analyze it and you're getting your results at a later time. So at that time of the end of shift or during the shift, you actually are not understanding if that worker has been exposed until you're getting your results back. And while those results are the gold standard and compliance standard of monitoring, it's a handy combination to have some real-time data to see where your exceedance has happened, because then you can immediately treat that risk. Okay, so you're looking at the peaks on your real-time monitor to see at what time in the day did that happen, and then can have a more pointed conversation with the person who's wearing that device and understand what are the tasks that are actually happening in those time periods where we're getting some very, very high exceedances. That initially identified hazard may not be the actual task that's generating the dust risk. So you're able to then identify those key points in the day at which the worker was using that device, and I would ask some more questions about it, because thinking back over the whole shift about what I had done when I was wearing my gravimetric filter collection can be tricky. But if I have some timestamped information, then I can actually use that as a conversation point. The real-time devices can be paired with video capture software. NIOSH has a program called Evade, which has been around for some time, where you can actually overlay your data from a real-time dust monitoring device with a video capture. We all have smartphones and GoPros available to us now, easily at our disposal. So we can actually utilize things like the DustCanary or the Nanozin to give us an overlay of data over some video captured information. Where that becomes really, really valuable is in the basis of task-based analysis. So if I'm doing a particular task that's a very, very high risk, I might want to understand where the dust peaks are happening throughout the duration of my task. And I also might want to just use that as a training tool to inform the rest of the workforce about why they might need to be clean shaven and where their RPE, or why we're actually going to utilize local exhaust ventilation and other mitigation practices. Again, from a management perspective as well, that gives a safety professional a tool to take up to management and decision makers to say, look, this is something we need to address, and we're needing to put some resources into rectifying and resolving an issue we have with dust emissions on the site. You're going to have the greater ability to relate data to the task or location where exceedances occur. So again, that's something we're working on the roadmap, and Shane Lenton will touch on later in the piece. He's our engineering manager, and he'll actually be able to give some detail about how we're going to be better relating that data to actual locations within a facility. So we're looking at things like RFID tagging and Bluetooth interface to our static monitors to be able to actually escalate that level of data again. So we also have the phenomenon happening around the globe of worker exposure limits reducing. Okay, so with the reduction of worker exposure limits, some intermittent compliance sampling is going to be trickier for us to manage without the use of other tools such as real-time monitoring. If I'm able to deploy real-time monitoring on the workforce while they're operating, say in an underground mine or in a facility where you're going to have significant RCS problems or diesel particulate matter issues, With those couple of items of contaminants of concern reducing, we're needing the technology to advance as well to be able to better understand those risks in practice every day. That's going to be very, very important in the next couple of years as we move from worker exposure standards to worker exposure limits, and we have some reductions in some contaminants of concern that we're going to have to put a lot of attention to in terms of its monitoring. Some of the technical limitations of dust monitoring we'll now talk about. So the gravimetric filter method does require lab analysis. You need to select the appropriate type of sampler and filter for the contaminant concern that you're monitoring for. And there's just a time lag that you're going to get from getting those lab results back, getting it together and reporting on it, and then being able to present that back to the staff or the management of that facility. So that's one of the inherent technical limitations of a personal sampling pump using a gravimetric method. For real-time dust monitoring, one of the big limitations of that is that it can't speciate out different contaminants of concern. So these monitors are looking at particle size fractions for the most part only, and that can make determination of whether it's RCS, coal dust, or diesel particulate matter quite problematic. So if we're unable to speciate that out, it's very difficult to attribute that to a worker exposure standard or a worker exposure limit. Okay, so that is one of the inherent considerations when selecting a real-time monitor, that at this stage it's a great combination with gravimetric sampling methods. Okay, what you can do for some sites where you have very, very consistent elements that you're cutting through, or say stone bench tops, or you're in a mine with a very repeatable type of stone in that that circumstance, you can actually set K-factor calibration factors on these devices to get closer to what you're actually cutting into, or the contaminant of concern. Where that would be important is actually setting trigger levels on your alarms. So if I have a mine where I've got 10% RCS content in my rock, I might want to put an alarm on the low side there so that my worker's getting an indication that that they're potentially seeing some RCS issues when they're creating dust, and to get out of the space before a whole work day has elapsed. You know, we might want to get them out of there immediately as soon as we hit a trigger point or a threshold. Another point where you can use that is looking at the fit protection factor that you may be using on, say, some RPE. You can actually use this to alert you whilst, once you surpass that fit protection factor. So another handy tool from that alarm and alerting perspective. And but certainly a limitation of those dust monitoring devices is the speciating out of different compounds or contaminants. The integrated filter and real-time sensors, another sort of limitation of those devices, that they can be quite bulky. In an item here that we have pictured, the hazardous, beautiful instrument. It's a real-time particulate monitor giving you a single mass concentration. However, the sensor arrangement for that can be quite bulky to put on the worker. What we want the worker to be able to do is go about their daily duties and undertake the tasks as they would normally do so. So we don't want to create any sort of ergonomic issues or undue stress for the worker while they're wearing those devices. So that's certainly a limitation, and you're also subject again to that time lag of getting a filter back in. I'll move on to a recent case study that we were able to do in our Perth office move. We had some plumbing construction work happening in the space there. So we had an opportunity created to test our DustCanary real-time monitors. The team who was doing this work was using dry cutting saws, no dust mitigation or water suppression on that device, and no extraction ventilation. They're also jackhammering, and it was a very, very small room. So cutting through concrete and tile. So again, it was going to create a significant dust hazard as we saw it. The team was wearing their RPE, which is the last line of defense for them in that hierarchy of control. And we wanted to be able to put this monitor in situ and be able to give them some indication of what was happening during those activities. So again, it's really a task-based activity analysis that we're undertaking here. On the right-hand side, we see the data portal for our DustCanary device, and we're seeing some really significant peaks. So we were able to show that to the workers post their activities, and it was a fantastic information tool about what they should be aware of when they're undertaking these activities, and perhaps look at things that are going to mitigate the risk of dust exposure, like extraction on tool. Water and extraction on tool would be a significant improvement to what was happening in that space at the time. and not just to rely on the last line of defense of PPE. Okay, so that was a fantastic opportunity to test and trial our DustCanary, and we're seeing peaks here of up to 7 milligrams per cube. So a very, very significant dust emission in that space. I'll move into the static monitoring techniques and opportunities and solutions. We're very proud to have an Australian-made certified dust monitor. We've been working on this device for the last 5 years. Shane and his team of engineers in Melbourne have done a fantastic job of integrating custom design elements into this, this system. What we have here pictured on the screen is our flagship dust monitor, which is a 5-fraction dust monitor for the hygiene spec, which is a PM1, 2.5, 4.25, 10 and TSP specification. We also do a environmental specific unit, which is a PM10 and 2.5. But fantastic unit. It really goes to the customer design interaction because we've had significant feedback from customers to come up with this model concept and then put it into practice. And ideally, we're looking to bring our personal monitoring domains and our static monitoring domains together and put that into a cloud, so we've got completely accessible, transparent data that the safety professional, the environmental professional can use in practice in the field. Onto the static monitoring techniques, opportunities and solutions. This is a picture of a recently deployed perimeter monitor. Perimeter monitoring is one of the typical domains for static instrumentation. We could be on the edge of a mine site, we could be on a refinery site. We're looking to understand what's emitting from our site as those dusts are being created. So that might be important from a community engagement perspective. It might be important from an environmental perspective, just to see that we're not emitting any hazards or contaminants from the site and where we're doing some operation. Construction boundary is extremely common, and even in the confined spaces such as tunneling, dust monitoring with gases and other ambient condition monitoring has certainly been a mainstay of our range for the static monitoring instrumentation. Those areas lend themselves to utilizing control loops. Shane Lenton and I come from an instrumentation and control background, so we're really excited to be able to get those innovations into our box so that we can actually see an ambient condition and drive some change, so we can escalate that up in the hierarchy of controls and put in some engineering intervention into that scenario where we're creating a hazard for the workers, or we're creating an environment that's a hazard to the environmental conditions of the site. So able to drive things like lights and siren. We can drive a fan speed interaction from those devices so we can ventilate an area. Really anything that this device has an output, so it can drive anything with some step up relay or another control element in line. So that's a pretty exciting thing to be able to use this as a sensory element in field and then be able to drive some change. So fantastic from that perspective. The devices for static often will also be able to cloud interface. So you have cellular connection, you've got the ability to hook into a site Wi-Fi, you can do a LAN fixed cable if you're in a tunneling environment, and you can also, we've just recently put one out in a very, very remote area that you're using a Skylink access. So satellite connected dust monitoring devices. So from really anywhere in the globe now, we can have that complete connectivity and visualization on what's happening in our spaces. So that's a fantastic advancement in the field of dust monitoring and environmental monitoring in general. So really exciting, and really part of this presentation is to bring those innovations to life with customer-led feedback. We like to take a design thinking approach to anything we're building, but for now that's enough from me on my side of the personal and static monitoring in terms of applications. I'm going to hand over to my esteemed colleague Shane Lenton, who's the manager of our engineering division, and he's going to tell you a little bit about what they do and the magic that happens in the engineering division of AirMet Scientific. So thank you very much all, and I'll hand over to Shane. Shane, thanks very much.
Excellent, thanks Andrew. And again, a warm welcome to you all. So I'll start with who we are. Starting with myself, I've been working with AirMet for almost 13 years, starting from a workshop and on-site service functions to now managing the engineering department. I personally have a serious passion for all things instrumentation, and am grateful to be in a position in which I can transfer this every day in supporting new and ongoing opportunities. The engineering team here at AirMet is built of a diverse bunch, all of which have been the result of identifying talent and promoting from within, which we are very proud of. What we do, as mentioned earlier, we are proud to provide a certified Australian-made product. All of our manufactured products are built, quality checked and validated in our head office based in Victoria. Our team of engineers are always eager to support the next project and really relish opportunities to do something bespoke in the ever-changing world that is instrumentation. What we are passionate about, our key driver is our customer experience, or as we call it, the customer journey. We have key initiatives internally, specifically focused in ensuring that our clients' requirements are at the forefront, ensuring you're informed and consulted as much as possible. We not only aim to ensure you are provided equipment to support your application, you're also supported with the guidance, training, and ongoing technical support to guarantee success. Moving on, integration of instrumentation and data has been identified as one of our most critical components for success. We offer a high level of flexibility to support our clients' needs, whether that is integrating a black globe to support wet bulb globe temperature readings in a tunneling environment, to supporting integration of 50 to 100 variables from high quality Svansec noise and vibration monitoring stations, as demonstrated on your screen. Speaking of which, starting from the left, we have our complete environmental monitoring suite. This setup comprises of the following instrumentation that is completely integrated to our internal platform LiveSense. We have the Svansec environmental noise monitor installed on a custom traverse arm, and the Svansec vibration monitoring system positioned between the tripod footing. Our AirMetER DX4 dust monitoring station is in the middle of the post, and our Riker ultrasonic weather station at the top of the mast. In the middle is some representative data captured from this monitoring station. Widgets have been created based on specific client requirements, ensuring the data represented is what they want to see. On the far right of your screen is our AirMetER AX monitoring station. This device is supporting our most recent tunneling specification, in which the client had a combination of over 30 variables for our device to ingest, compute, and present again on a customized platform for their specific needs. An interesting addition to their requirement was the ability to include a local display to support routine bump testing activities and an external strobe light and sounder to act as local indication of an alarm event occurring. This, coupled with the SMS and email notification to staff, has proven to provide a comprehensive solution for their requirements. Our dust monitoring roadmap. So Q1, we have a 6-way charger for the DustCanary. So we're providing a ground-up functional design and development of a custom solution to support charging multiple DustCanaries, either in a fixed environment, i.e. mounted to the wall, or semi-fixed on a standard benchtop solution. QT, we're looking into real-time data access and an API for the DustCanary. Data is currently accessible manually through the DustCanary's web-based application, in which data is transferred via a Bluetooth connection. Whilst this achieves the simple function of retrieving your valuable data, we've identified the need to improve this component. The aim will be to provide flow of data through the device to our existing LiveSense data portal, in which sessional and live data can be recorded, logged, and even present the possibility to notify select users of alarm events. Complementary to this activity, we have identified the need to investigate a functional API to support data export from the DustCanary to an external network. Whilst we are confident in our cloud platform to meet your specific requirements, we've heard the request from our clients to ensure this is available, and we're here to follow through on that request. Q3, we have our customer data portal. With again the customer experience at the forefront, we will begin works to support an AirMet client database in which sessional and/or real-time historical data may be archived and stored for equipment you own, rent, or loan from AirMet Scientific. Again, we've heard your feedback, and we'll be executing a solution that supports this requirement and provides you with the best user experience possible. Q4, we have our AirMetER DX5 release. The AirMetER DX has been in operation for 5 years here in Australia and abroad. In its current iteration, the DX4 is supporting our current client demands well with 5 fractions of particulate and active flow monitoring. Motivated primarily by our own internal desires for continuous improvement for our products, we will deliver the latest improvements without impacting the deliverable price to you. Watch this space, as we will be sure to keep you updated with the upcoming hardware and software upgrades as we can continue to develop this range. This now concludes my component of the presentation. I would like to take this opportunity to thank you all for attending as we progress into the QA component.
Excellent. Thanks, Shane. And we've got some questions through on the chat, so that's fantastic. We might get right into the discussion on that. So I'll be reading out the questions, and between myself and Shane, we'll answer them as best as possible. If there's any questions that we can't get to today, then we'll communicate those back directly. When the GoToWebinar link goes out as well, we'll have some contact information for those of you that are unable to join us for today's session and the interactive Q&A, that you have a conduit to come back to Shane and I and discuss these opportunities or innovations directly with us and take up that conversation on the design thinking approach to a roadmap for pioneering dust monitoring instrumentation. So without further ado, I'll get into the questions we've had thus far. We've got a great question here about minimizing the impact of water spray, so dust control measures, and how is that being detected by a real-time instrument as a false reading. So what I take out of that is basically on our static monitoring systems, we're going to use a heated inlet design to remove any moisture particle or misrepresentation of particle size in that monitoring system. When you're looking at a personal device, due to battery life and considerations of size, we don't have a heating sample system on, say, things like the DustCanary. So certainly there is a condensing RH limitation to the use of those devices in practice in an area where you might be heavily spraying water spray throughout, using an optical sensor. So obviously any moisture getting into those electronics and optics can be problematic if you're not heating that sample, but certainly on all of our static monitoring range, we utilize only heated inlets, because we find that if you're in fogging situations, or you're in situations where you are mitigating dust and using control measures such as water spray, that you can misrepresent that, that water vapor as a particle. So that's certainly inherent to some of the other low-cost fan-based sensors that are more urban air type systems that you see in some construction sites now, that's an inherent issue with some of those devices. So we've moved completely away from that system on our AirMetER range for the statics, and we use only a heated inlet design to be able to ensure that you're getting true readings through there. Next question we had was, is there a field calibration requirement for the DustCanary? So no, we don't have a field calibration requirement on the DustCanary. Being a small size and a fan-based system, we don't do any flow rate calibration with, say, a rotameter as you would do on a SKC pump, for instance. So those are calibrated from the factory. We get our sensors calibrated in an environmental chamber. Perhaps Shane, if you wanted to elaborate more on that, you've been across that calibration factor for the DustCanary.
Yeah, so each sensor is certified by the manufacturer. So every DustCanary sensor that we're supplying with the equipment or is being replaced in the field is carrying its own certification. There is a K factor, a manual adjustment in the software. So if you are doing a gravimetric sample on site, you can make a field adjustment in the field, but that would be a question for later, I suppose.
Yeah, that wouldn't be essentially the field flow cal. You wouldn't be undertaking that on a DustCanary. They're really designed to be able to deploy alongside your gravimetric sample, or in between the compliance sampling activities, to see where you're getting peaks and hot spotting, and be able to have a lot more data at your disposal to go and identify areas of concern. So that's where they would really come into their straps. We've had another question here. Are there any height requirements for the static monitors? We tend to put the static monitors, if you're putting them into, say, a tunneling environment where the occupants will be, you're looking at, again, a surrogate breathing zone, if you will. And again, if you're putting them on a boundary of a site, you're going to have considerations of what does the site look like in terms of hills and airflow and things like that. So if you're obviously putting them in a bit of a dead spot of airflow, then you're not going to get a really representative sample of what's happening on your site. So that would be one of the considerations of deploying a static monitor to the boundary, is certainly where where you're going to place that device. If you've got some construction boundary where they've jersey barriered and they've put black plastic on a fence line and you've got your dust monitor sitting below that line and behind it, that's going to be very problematic for it to get a good representative read on what's happening on the site. So clear airflow, we deploy our units on a 1.8 meter tripod for the most part for site boundary, or if you're working on a construction boundary, say, or a mining boundary where you do have some fencing, you're going to fix that unit to any pole or any structure there with a very flexible worm and screwdriver arrangement to set that unit up. So there's no real exact location where you're going to put your static monitoring. It's very site specific. But if you're looking at that tunneling environment, I would be putting it where my occupants tend to reside is kind of the best practice for that one. We have had a really great question here about pest and ant control, which we definitely have seen, because our heated inlets can be like a little hotel for pests and ants. So we use a fine total suspended particulate head on our devices, which certainly stop the the insect taking residence in there. But we've seen quite a few spiders in our time on some of our solar kits. They like to take residence in the local hotel that gives them a nice warm space to operate in. So those can be sort of the site establishment factors that you might need to put some control in there. We haven't seen with regular maintenance or checking of the devices any sort of odd issues with readings, because our units tend to be very pest free. But the actual solar batteries tend to be a place where you might find some resident ants. So if you're putting some pest control measures in those battery boxes, that's great. And if you're scared of spiders and some of those things, then just beware when you open a lid sometimes that you could find a little friend in there. So it's certainly something we've seen when you're leaving them out for years and years and years over time. Just some good housekeeping is good to do every so often on the units. We use an integrated flow control on our static monitors now, so you're able to see when you're having a flow issue. So that's indicating something like a pump protection filter is blocked, or you've had something block up your inlet. So you're able to see that happening in real time on your LiveSense portal. So that's certainly a good feature. But if you're out there on site checking other static monitor, if you're doing boundary monitoring for dust migration of some gravimetric sample, whilst you're out there, you can do an inlet flow rate check or a clean of your system as well. And if you're operating in the tunneling environment, then certainly you would tend to be subject to higher levels of dust behind something like a TBM. And that environment is somewhere where you're going to be changing filters a little bit more regularly than the outdoor ambient conditions. Shane, anything to add on that side of things in terms of maintenance and pest
I think
control?
highlighting the need for the regular routine maintenance is the most critical component. One thing to add is that the engineering team here, we're conducting sanity checks quite regularly as well. So remotely, without your input, we're seeing what's happening on the background, and we can see those sorts of things occurring. If we're seeing flow rates dipping, then we can be on the front foot contacting you to say, hey, it looks like there's an issue, needs a bit of investigation, or can we support you by sending out a service technician to assist?
Yep, absolutely. We've had a really good comment and question here on the question chat as well about the distinction of real-time monitors from gravimetric. The differentiation of size fractions, aerodynamic size is not necessarily the equivalent of particle size determined through light scattering. An important distinction means real-time monitoring will never be able to replace the official gravimetric analysis. I would agree. I think it's a complementary tool at this stage, and it's somewhere where I can use it to zone in and be able to quickly address when I've got some issues. So I'm really looking at those peaks on a real-time monitor, and the complementary nature of it going alongside your gravimetric is great. And it's also that in-between time where if I'm doing no monitoring, I can put real-time monitors on my people daily and actually see if I'm getting some other issues that I wasn't usually exposed to. You might have somebody jumping out of routine, not sticking to their structure of their day and going a little bit outside the box, and you find that you got a peak. So that's when you might trigger that time to do a compliance sample with a question around what actually happened in that context. and you have a bit more data at your disposal to take an action. That's how we see that that real-time monitoring complementing the use of gravimetric sampling. Absolutely. We've also had some more questions in here. Let me just go to those. We've had one here about reference material in the DustCanary, measuring a concentration in the rough ballpark of the air or dust concentration. So Shane, if you wouldn't mind talking just a little bit about that calibration principle on the DustCanary again, that's what we would we'd see adding a bit of value there, and then I can jump into a little bit of testing that we're doing post that.
Yes. So I guess I alluded to that previously. The manufacturer, through its Terra sensor, they certify, they do a reference calibration for every sensor that they provide, and we receive a report, which as the end user you will too, and that'll be against Arizona road dust as the reference material, and that'll be every single sensor.
Fantastic. And just on that as well, we're actually looking to do, well, we're doing a co-location trial. We're putting 4 DustCanaries out for a university study, and it will be going alongside with traditional gravimetric methods to really understand where they sit. So it's going to be put through its paces in a couple of different iterations. So we'll have 2 DustCanaries running without a filter to take out any particles higher than the respirable dust. And we've got 2 DustCanaries also running on that, that testing scenario with IOM filters integrated too. So scrubbing out any of that potential moisture or higher particle size getting through the sensor, and really testing the accuracy and effectiveness versus traditional methods of, say, a cyclone measurement through a gravimetric pump. So that'd be a very interesting study, and something we're looking forward to being a part of. There'll be nanozins and there'll be DustCanaries participating in that trial that's happening in WA, and we'll enjoy putting that through as some research paperwork after the trial's taken place and we get the publication. So that'd be a fantastic one to understand where these devices sit against traditional methods. So we calibrate to those lab conditions, but we really want to see what it does in the field as well. So that'd be a nice study to be a part of. We've got another question about alignment of methodologies for Australian standards, or is it, and the question is it aligning to standards, or is it primarily used as a screening tool for further investigation? I would say the latter, the screening tool. You know, it's used to get masses of data quickly. So we're not using a DustCanary, a real-time monitor, to overtake a compliance sampling method with a pump. That's not going to happen. We're using it as a complementary tool. So you can use it as a quick screening, or even if you're a hygiene consultant working on sites, you can have these as leave behind assets for some competent person to put on the workers in lieu of you being there every day, and be able to acquire a lot more data. So that's something, again, that gives you a bit more eyes and ears on the ground, in place of being there to do the gravimetric personal sampling on the worker at the time. So, you know, with that, with a little bit of housekeeping of the areas and locations that the people are operating in, then you can understand where you might have some hotspots to address that weren't addressed on the walkthrough survey and in the initial visit of the plant or the area where you're going to. We have another question here on weld fume testing. Currently using a dust track. Is this more of an accurate tool to use compared with, so the weld fume testing, you're looking to probably look at the total suspended particles. I wouldn't say one's more accurate than the other. Depends how you're sampling. I mean, the weld fume testing, again, would always be with your filter analysis or using your SKC pump. And again, you might have a combination of gas tube in there if you're looking to understand what sort of gases are present in that activation as well. But yeah, that's certainly been one of the worker exposure standards that's reduced. There's a big push to do more monitoring in some occupations that have probably been a little bit under tested. So there's certainly options for that, and we can share some options on how you would undertake that sampling post the webinar. I would see any of those real-time devices really sitting as dust track, or a static monitor would probably be the ideal selection in that case, to put in something like a DX for an understanding of the particle breakdown. So you might not be looking at just one particle size. You might want to see what the makeup is of multiple fractions, and then can make a decision on changing some control efforts there. So that's how I would use a real-time monitor in that scenario. Put something in like a DX, an AirMetER DX, and then you're able to put in even strobe siren control activation via some exhaust, so you can actually set up the loop systems. I say that's something that's a little different to what you might do with a point and shoot type of other brand real-time monitor. We have another question here. RCS readings results, can they be accessed live on a DustCanary, and how accurate are these results? So we do not speciate the type of contaminant when we're using, say, a DustCanary. We're looking at a respirable dust mass concentration only. So again, that would be something that would be lab result analyzed. Is our contention on that you should get those results analyzed at a lab for a compliant sample. We understand that some other brands would claim RCS, but I think that's been in some forums discussed, and the accuracy of that is undetermined. So we don't claim that the DustCanary does speciate RCS. What you could do is you could look at, say, a stone bench top company that's cutting through 95% RCS content benches every day of the week, all day, never changing, and put a calibration factor in there to set an alarm. That's all I would use that sort of K factor or correction on, is to actually give me an earlier warning to my worker when I've potentially got an issue. We can, on our static monitors, put a surrogate sensor over our LiveSense cloud as well. So you can look, if you have compliance readings from your historical readings that you've sampled, you can actually run a virtual sensor over those units as well. But again, it's not an accurate RCS content because things can change, and we can't determine when you're cutting into new rock or something different. So you need to really understand the site conditions, and if things aren't changing rapidly, you can use this surrogate as a early warning only, and that's how I would take that reading, rather than gospel that is RCS content in that sample. Some of these sensors have gravimetric samplers, but I don't see other documents suggesting that they align with Australian respirable dust sampling standards. Certainly, Nanozen is using an impactor. It's using a 1 litre flow rate, so it's not a compliant monitor in terms of taking an RCS sample. What you can do with that unit, having an inline 25mm filter, is that you can get that analysed at the lab to see your respirable dust concentration and also your RCS content. So you can have that analysis done and actually overlay that with the result that you got. So you got to start building a picture of the calibration factor that you want to put on that machine for that particular area, rather than use that as a compliant sample logging moment. We've got another question here, which I'll just start going through. User guide for the DustCanary outlines aerolic filter, not able to cope in areas with greater than 1 milligram of dust. I found that they will overload and go into protection mode quite quickly in high dust areas. Can you speak to these limitations? Is there work underway to improve the sensitivity of the filter? Some of these high peak graphs appear to be indicative of overload. Okay, great. So yeah, that's a fantastic question to add. And we, as the manufacturer of those products, can certainly look to changing how that system works. It's really a protection filter, so you don't get a clogging on those units and have to replace your optical sensor. When you're running that line very quickly into the optical sensor, that it will become clogged and can misrepresent dust particles. Shane, that's probably something to put on the roadmap post this webinar, I would suggest, as a user-led comment, which is fantastic to get. And that certainly goes into the roadmap of upgrade and change that we're going to be doing into the DustCanary. So that pump protection mode is an inherited part of the DustCanary, and something we'll put on the roadmap to change. So thank you for that information. And I think we've got some other ones on how do we manage continuous field data as well. That's an interesting question. So and that's at the time of calibration. So if you've got a unit where typically the sensor is going to be an annual calibration for your dust monitors, we actually have the facility to do hot swapping of any of those sensors that are AirMet house products. So things that you might have like a static AirMetER DX unit, you can actually have in the field, and we either hot swap the whole unit or we hot swap your sensor. Shane also mentioned we've got service technicians all around the country, so we can be engaged to do the commissioning elements of those systems in the field, and we can also assist with any user calibration times too. But if you're in an extremely remote area and it's very difficult for us to drop out to see you, then you can certainly do it yourself, because everything is a very plug and play system, and took a customer design approach to building this unit. So Shane, is there anything you wanted to add on that that servicing point?
No, I think you've covered that. I guess it's just, again, to reiterate, the simplicity is probably what I'd add. It's just a very simple thing to do. And it's, yeah, most clients have a lot of confidence in doing it. So, yeah.
Yeah, fantastic. Okay, I've got another question just pop in. Fantastic, thank you for that. Any plans to reduce the size of the DustCanary in the future? Absolutely. With technology changing, we would love to see it as basically as small as possible. So we've looked at things like, can we forego the screen? Can we make that device, something much smaller to be, say, like a noise dose badge size? So absolutely something we're looking at the moment. Our 420 dust monitor is something that we're sticking with for the most part, but anything on that size reduction of anything to make that user experience or the wearer feel a little bit more comfortable is something we will progress along to. And Shane, if there's anything you'd like to add on that, mate, feel free.
Yeah, I think it's certainly a part of the roadmap on a bit of a side step. But yeah, at the moment we're sort of just gathering feedback, input from users, and then we can build a better approach as to what that roadmap will look like in the next year.
Excellent, great. So we'll wait a couple minutes if there's anybody else got some comments or feedback on the roadmap, something on if we're looking at the integration of personal monitoring and static world. If there's any commentary on that, we'd love to hear it. For some of you may have seen our cloud platform. For those of you that would like to, we're happy to engage in sort of an independent session with you at another point to be able to see the flexibility that gives you in field. So bringing up that visibility of personal monitors is something we would love to see, and we'd love to hear feedback from people who are doing this in practice in those domains to see what sort of value that would add. Looking good. Well, look, thank you so much for joining us today. It's been excellent, and your feedback is appreciated. It's important. Shane and I like to take a customer design-led approach to anything that we're developing, and AirMet does the same. So our customers come first, and we want to hear from you. So post this webinar, we will send you out the link of the session so that you can review and watch it back when you have a little more time. If there's questions that come to you later down the track, we would love to hear from you, and we'd love to work with you on solutions that we can put forward for monitoring. So thank you so much for joining us today. It's been a pleasure, and we look forward to hearing from you all soon. Thank you. Thank you all.